Hopefully you guys enjoy it, and it's not as like research based. This is kind of a passion project that is, and I mean a really important tool that we've been using in the lab. A lot of the research that you've heard about today, I mean certainly the stuff from EchoNest, comes from this massive data collection initiative that we've been pretty tirelessly continuing trying to collect. So for this one, I'm going to very briefly talk about open access music data and APIs. I think this crowd has a pretty good understanding of what these are, so probably don't need to spend that much time on that. And then I'm just going to talk about what this thing called Grail is that we're working on, and how far we are along, and what we hope to do with it. So we know EchoNest, we just heard a lot about them. APIs are great. I mean, for someone like me, I had no programming experience at all last year around July. And then I came to this lab and I learned about APIs. I thought they were the coolest thing ever. You could get all this information about every song ever. Like, really? Maybe not every song ever, but like bigger numbers than my brain could process. This was amazing. So you could do such high level meta-analysis with these APIs. I mean, this is an audio summary with this nebulous instrumentalness isn't in this example for them, but yeah, it would be there if this sample had this recorded or had that there. But APIs for academia, although they don't seem like they may be able to do a lot, can do a lot of really cool things. Yeehaw in our lab was looking at natural language processing of song lyrics. There's a song lyric API out there that has all these songs with all the lyrics that you could possibly want to mine. Last.fm provides user listening consumption data quite similar to what our database has. So you don't even need to have friends at Mix Radio, guys. You can start collecting music consumption data on your own. And some of it might actually have finer resolution from Last.fm than what we have sometimes. Like, we don't have demographic information about our users. Last.fm has self-reported demographic information, but they're all the same. BBC Music, I mean, this is Acoustic Brains. We heard about Music Brains a little bit. This great resource for music metadata, finding out like if this is a band, when did they start, what country did they begin in. Like, this is a really interesting thing from Music Brains, but Acoustic Brains is their a side project that does a lot of their advanced analytics. So a lot of really cool research comes out in Izmir, and then some of those algorithms just get put right into here with their fantastic metadata. BBC has an API as well, and some media resources will give out their data or give out these services. And I thought this is really interesting here specifically. They say, here are some of the best BBC APIs for you to remix and mash up with. And why is this remix and mashup thing important for people like us? And the reason is because, okay, has anyone here been to a hackathon? Yeah, okay, so yeah. So you know if you've been to a hackathon that you're not going to win or even get anyone's attention if you use one API. And there's a reason for that. And it's because that company has made that API. They've farmed their data like crazy. They've mined everything that they need. They might have new ideas coming forward, but they know their data set better than anyone else. But what they don't do as well is know what other services are doing as well, right? They're not as interested in like comparing their data sets, because if they link them together, that maybe that's some compromise and they lose out on profits or something potentially. But within the APIs and other areas have some linking, but in music it can be quite challenging. It's difficult to get information from Last.fm and then go all the way to EchoNest. You have to take a couple of steps. And for a newbie like me, who was kind of learning Python and learning this big data world, this is a huge barrier of entry. It's hard to jump around. It takes a lot of extra time. Not to mention API documentation is good sometimes and shoddy at other times. Perfect example is Last.fm has some secret methods for their API that they don't document that make your crawling a lot easier. And they don't mention it at all. So there are a lot of things that these companies sometimes hide from you as well, because maybe it just makes your job too easy, or they're they don't really care about their documentation as much as we would necessarily. So this is hard. And why would we want? We would like to have a better system that makes it easier to get the data that's already available for all of us to use, just quicker and with less problems, less bugs, less errors, less fails. So that's what Grail tries to do. It's this hub of music metadata, kind of like MusicBrainz, but with different things that I think are probably more valuable, not necessarily more valuable, but are more valuable for linking APIs together. So we want to, the purpose of Grail is to simplify MIR. It's kind of nice that we're talking about this at the end because it kind of closes off this MIR thing we're talking about. But also we want to unify this data. Like, it would be great if we could get some EchoNest audio summary information and then some MusicBrainz information all in one spot, so that you didn't have to jump between these different things and hope that you get the right track for what you're looking for. Because with 37 million, it's easy to make a mistake. Like a love song, there can be many track names with that same love song, for instance. So making sure that you have the right ID and the right data for your large corpus is really important. So having that linkage is necessary, at least for us. So I built this code in Python. We call this project Grail, and my boss is English. So if I don't have some Monty Python references in here, I'm going to get in trouble or get fired or something. So here's Grail, and we're Grail Knights. We want this project to be real, and we want this to be something that is like an open API for everyone to use. And the purpose of Grail, kind of at this meta level, is to expand research opportunities by expanding the data that is available for people to use. It's hard to have these kind of like CogMIR, like a mix of cognitive research with music information retrieval if you don't know what information you have, right? So having more within the academic sector, at least, allows us to ask more kinds of questions. Linking this data in ways will, and creating new and innovative ideas or projects or research is beneficial. It's pro-social. It allows academia to succeed and do well, and it also provides some interesting benefits for the private sector as well. They benefit from the research that comes out of it that everyone can use and has an equal advantage using, but it also allows private sectors to kind of brag, like, yeah, we're open, we love our community, we want, you know, this kind of environment. And so it makes them look good too. Lastly, for someone like me, this matters. Sure, it's fairly easy to go to an API and get one little thing that you need, and then if you have enough time, go to another. But if we make it easier for everybody, more people can contribute, more people can innovate. We have more cross and interdisciplinary individuals that can really promote and come up with new great ideas. So that's all well and good. Like, sounds like a great idea, right, Mike? But how are you going to do it? So we started our scraping process for EchoNest and for Spotify prior to this without a web crawler. That was hard because it fails a lot. We learn something, like, there's a problem that happens. Okay, well, we got to go fix it. We got to turn it back on. We were basically being janitors for our own scripts all the time. I would hours. Just every day I'd check to make sure my scripts are running like 10, 15 times a day. Like, just, it's an obsessive process. So we wanted to make a web crawler that would take us out of the equation a little bit, that allows us to scrape what we want, have it modular so we can move APIs, so get new data from other places, runs concurrently, so always running it asynchronously, so having many different scrapes, many different crawls at the same time, and has some level of autonomy, like knows what to do if it if it faces a problem. So I'm going to go through this a little quickly because I think we have the technical knowledge to understand this fairly well. I can slow this down if you guys need, but I'm trying to like finish this up a little bit for you guys so we can all get out of here and, you know, have coffee and stuff. So we start with our Grail. Grail is the beginning of the database. We put some seed information into this that we can use to talk to other APIs and get information from them. So most of the work most of the magic kind of happens at the scheduler. We give data to a scheduler and we tell the scheduler, hey, I want this information. You need to go to this point, try this value or this ID. You can only try this amount of times. Look for these things and come back to me. What that ends up looking like is you send, so the scheduler will tell a worker, hey, we need to go to Spotify. So I'm going to start with, this example is actually how we basically scraped Echo Nest. So we had a large corpus of ISRCs. Those are International Standard Recording Codes. You can think of them as like barcodes for songs if they're going to be distributed internationally. It happens at the mastering level. So we tell Grail to go to the scheduler and say, hey, I want some information from Spotify. They have this really cool thing. Spotify accepts an ISRC as a value for us to pull information from. So we tell this worker, go to Spotify and do something for us. If it succeeds, great, that's awesome. Let's put that data back into Grail. If it fails, it tells the scheduler, it tells it why it failed. So if it failed because, I don't know, it just had a connection problem, that ISRC will go back into the scheduler and it'll try again at a later time. But if it was an error that it doesn't really know what to do with, or we've never encountered it before, it'll log it. It'll put that ISRC away and say, we had a problem with this one. And then we can deal with that later on, depending on what the problem is. So this is what makes this kind of schema here is modular, because we can add many workers. We can point the workers at other places. It's not really asynchronous at this level, because it's only one API, right? It can be kind of asynchronous if we had 10 workers going at the same time, but that's a little bit of a cheat. But it does have some autonomy at this level. Where we make it asynchronous is once it gets back to here. So if we wanted to look at Echo Nest information, Echo Nest doesn't like ISRCs, but it likes Spotify IDs. By like, I mean it accepts them. So with Spotify, we get a Spotify ID, it goes back into Grail. When this process happens, Grail tells the scheduler, I got a new Spotify ID. We should go to Echo Nest and get those audio summaries and find out what's going on with instrumentalness, right? So then it'll go to the scheduler, goes to Echo Nest, and runs the same thing. So this is really where it becomes asynchronous, because you can get like, if Spotify does, if you've crawled and scraped all of the Spotify IDs that you currently have, the scheduler just waits, right? But let's say you get a big dump of 50 Spotify IDs for whatever reason. It'll then go to spawn up a worker and then go there. So this is really the point where it's autonomous and asynchronous, concurrent, and modular. And with this setup, the sky's the limit. It really doesn't matter what API you hit, so long as you have the criteria that you need to tell the scheduler. So I was alluding to before with Last.fm that you can get your own consumption data right now. With a scheduler and a web crawler, you can. You can go to Last.fm, find users that you want. If you only want to look at Canadian users, you can say, hey, Last.fm, let's, I want to look through all of your users, but I only want Canadian ones. So it would go to Last.fm, try and find a Canadian user. If that user wasn't Canadian, fails, moves on. But if it were Canadian, you would succeed, and you can put that data into Atlantis, which is just a fake name that I use for like Last.fm consumption data. It's just another mythical term, I guess. It was suitable for this talk. But that's really where this kind of 4 levels of web crawling is where we need. And this allows us to just step away. You know, we can turn this on and let it go on in perpetuity unless some sort of catastrophic bug happens, which we would obviously deal with. So, how have we done so far? Probably the best way to ask this question is, have anyone else done this before? They have. So this is when the Grail Knights encounter their crazy bunny, right? And they all run away. But we have a holy hand grenade. Don't worry. So bear with me for a little longer. So this is another API. This is called Music Story. Music Story is kind of trying to do what we are. They're trying to build metadata. They're trying to have this great resource where all these different companies that are affiliated with them, MTV, Virgin Radio, I saw Amazon, the French government really loved these guys. They gave them like £600,000 to like continue their service. They really believe in this company. But one thing that they're very open about and proud to show is how much they've scraped, how much they've gathered. So they have all this really cool information. You can check it out for yourself if you'd like. I've truncated the relevant results into this table here. So we didn't scrape everything that Music Story currently has. Our focus has been trying to get ID spaces, because that's the key, right? This is what allows you to unlock an API. So we've gathered a lot of IDs. This number, I ran this MusicBrainz track collection starting last week. It just finished this morning. I thought it was going to hit 500,000. It got to 450,000. I really wish I had that extra 5 zeros, but that was okay. This MusicBrainz track IDs, a lot of APIs have connected, but this is hard to connect to things like ISRCs. This information is not readily available in most APIs, like a matching of MusicBrainz tracks to ISRCs. You can maybe scrape it from some, but it is truly a pretty unique linkage there. But I mean, when you compare our ID spaces to theirs, we're doing pretty good. I'd say we like triple in most cases, something like that. Yeah. We also did a separate thing. This wasn't a web crawl. James, who's a co-author on this paper, downloaded Wikipedia. Like it's about 40, 50 gigs, and he scraped all the MusicBrainz information and all the people data that we could possibly get from that data dump from Wikipedia, and that's the linkage we got to Wikipedia artists. So what I want to do with Grail is continue to fill the cup, I guess. It was the best way to kind of keep this metaphor going. People data is really interesting, and that's a big focus of our lab right now. We have lots of artist information, but we know that an artist is sometimes a band, it's sometimes a person, right? So an artist is really more of an entity in a lot of ways when it comes to music, if you don't know whether or not they're a person. And this stuff kind of falls nicely in line with our music recommendation based on secondary artist features. So or secondary artists in general. So if we can start to link people to either their corresponding bands, to how they've produced, if they've produced anything, if they've been a lyricist on something, if they're a singer or a bassist, if we can really nail people and their roles within the music industry, we might be able to have a novel recommendation, or at least a novel way of looking at how people are listening and downloading music. We had a lovely comment from Frank about genres with my previous talk, and like, we only have 63 and stuff. This is part of the reason why we work on Grail, or why I work on Grail, because there's better genre data out there in the world. I mean, Echo Nest has like arrays of genres. Most of our genre information is a single tag. So we would like to enhance our genre information, have real subgenres. We have some of the genres in our database could maybe be subgenres, some of them not so much. So if we can refine that metadata, that would have new avenues of research for us to explore. There's 1,000 things I'd like to look at with subgenre. We would like to link Grail to lyric data. Obviously, we had a talk about sentiment analysis and song lyrics for Mandarin pop songs. What if we did that for all genres, or any song? That would be very valuable, very interesting for linguists as well as anyone interested in, sentiment analysis on effectively poetry in a lot of ways. We want to make this collection, this Grail, an API that everyone can use. We want it open. That's something that's really important to me at a personal level, because I believe I really support the open access, open source community. And this is something that, music, as much as it's created by artists, it's consumed by us. It belongs to all of us in a lot of ways. So having that metadata that doesn't directly jeopardize profits for the artist, but it's still something that we keep and store and collect, almost like archive, I think is valuable. And lastly, more ID spaces. One of the most common questions I get when I talk about this stuff is, okay, music consumption, digital downloads, very cool. What about what people are listening to while they're playing video games? That's a question I've gotten before, and it's an interesting question. Music Story has Xbox music IDs. There are other there are other sources. Spotify is linked with PlayStation 4. So maybe one day Spotify's API will start releasing consumption information from PS4s or other video gaming software. And lastly, Amazon IDs can show you consumption, like actual purchasing, right? So really the sky's the limit. APIs are born all the time, right? So the whole point of the modularity is that when new things come around, we can link that as well, and it shouldn't take that much time. Like, it's there for us. That's about it. Thanks, guys.
Is it legal to reshare this data? I mean, I imagine like music brains, obviously you can, but Echo Nest, there's normally an agreement I think that you sign to get an API key.
Yeah, but when it's at a so some of them are, but a lot, like I think Echo Nest allows it's so long as you don't profit from it, and because we're an academic institution.
Yeah.
I mean, maybe some of the things that we would want to share in the API openly, we wouldn't be able to share. But we want to share as much as we can.
Yeah, so Eric, you raise a very good point there.
Yeah.
I can get something from you that I couldn't get from somewhere else.
Well, that's not necessarily. You could get it from me that you could get it from somewhere else. It'd just take you a lot longer to get there. That's the point of Grail.
Well, if the one entity had an agreement that said you can't use this for profit, and you didn't have that agreement.
Yeah, but we're not trying to profit at all.
The idea.
Somebody could get it from you and use it for profit.
Yeah.
So
The ideal is for it to be open source.
Yeah.
The reality may be very, very different.
Yeah, I should probably have prefaced that. It's a dream. I want it open, but whether or not we can actually make that happen is, we'll see in the future.
We're using it for research.
We are using it for personal research. Yeah.
You can always,
which are non-profit.
Yeah, you can always put it up on Amazon, in the cloud somewhere and share
Yeah.
it with all your friends.
Yeah. Yeah. So it is on Amazon, actually. Yeah.
yes.
All right. So thank you again.
Yeah. Thank you very much.
So we've reached the end of the day, and before we all go our separate ways, just a few conclusions.